नमस्कार, मी डॉक्टर नागेश सूर्यवंशी घेऊन आले आपल्यासाठी हायड्रोलॉजी या विषयातील आपल्या मातृभाषेत मराठीमध्ये व्हिडिओज. आजचा विषय आहे रेनगेज स्टेशनच्या संबंधित आहे. त्याची ॲडिक्वेसी चेक करायची. ऑप्टिमम नंबर ऑफ रेनगेज किती लागत आहेत त्या पर्टिक्युलर एरियासाठी ते कॅल्क्युलेट करायचे. त्यासाठी काही स्टेप्स आहेत, त्या आपण स्टेप्स पाहूया. त्याच्यानंतर आपण एक एक्झरसाइज पाहू. त्या एक्झरसाइज पाहिल्यानंतर तुमच्या लक्षात येईल की ऑप्टिमम नंबर ऑफ रेनगेज कसे कॅल्क्युलेट करायचे. तर चला पाहूया स्टेप्स टू कॅल्क्युलेट ऑप्टिमम नंबर ऑफ रेनगेजेस. So the formula is n is equal to CV upon E bracket raised to 2, wherein the CV is the coefficient of variation of rainfall in percentages, and E small e, that is the allowable degree of error in the measurement of the precipitation, that is also in percentages. If there are m stations with rainfall values P1, P2, P3 up to Pm, then coefficient of variation is to be calculated by the formula CV is equal to 100 sigma upon mean value of the rainfall, that is P bar. So CV is equal to 100 sigma by P bar. So where, as I told, P bar is the average rainfall. So how to calculate the average rainfall? Average rainfall is calculated by the sum of all the rainfall data given divided by the that particular m, means number of that particular stations, rain gauge stations, and sigma, that we know the standard deviation we have. Now to calculate that sigma, there is a formula that is sigma is equal to under root of summation of that pi minus p bar bracket raised to 2 divided by m minus 1. See the formula that to calculate the standard deviation. Now that by these number of steps we will calculate the value of that optimum number of rain gauge say required by the CV by E bracket raised to 2. So now see the exercise, and by that exercise we will come to know that how to calculate optimum number of rain gauges. See the exercise now. Now exercise, look at the exercise. You can write down that exercise here. I read it. A catchment area has 7 rain gauge stations. In a year, annual rainfall recorded by the gauges are given in the table. So there are 7 rain gauges P, Q, R, S, T, U and V, and rainfall corresponding to each rain gauge that is given. For the P is equal to, the rainfall is 130, for Q 142.1, for R 118.2, for S 108.5, for T 165.2, for U 102.1, for V 146.9, all rainfall measured in a centimeter. So this is the given data, that rainfall over the 7 station. For a 5% error in the estimation of the mean rainfall or average rainfall, calculate the minimum number of additional stations required to be established in the catchment. So this is the question, that minimum number of rain gauge stations required to be established, that we have to calculate for a particular catchment area, right? So this is the exercise. You can write that exercise, and as by using the number of steps as we have seen earlier, that we have to solve that particular question. Okay, let us see that the question that we have to see answer for the particular question, that as we know the existing number of rain gauges that are total 7. The given data is that existing number of rain gauges equal to 7. Error that is given 5%. Now the first step, that we calculate the mean rainfall from the given rainfall data of the 7 stations. Sum of the all rainfalls that given that sum in the numerator divided by the number of rain gauges, that are 7. So by that we get the mean rainfall is equal to 130.428 centimeter. Now here is the calculations of P bar. Now we have to calculate the sigma, that is standard deviation. So standard deviation, that is calculated by the formula under root of summation of Pi minus P bar bracket raised to 2 upon m minus 1, right? So here the Pi means the stations, that is precipitations at the number of stations. So there are 7 stations. So for example, we have the data for first station, that particular P is 130. So here it is shown 130 minus that P bar, that is 130.428 bracket raised to 2. Likewise, sum of all that you have to do in the under root divided by the m means number of rain gauges, that is 7 minus 1. So this gives us sigma is equal to 22.545 centimeter. So here is the calculation of the sigma to us. Now by this we have to calculate the coefficient of variation by the formula 100 into sigma divided by P bar, that is the mean rainfall. So we have calculated sigma, we have calculated P bar. You have to put the value in the formula and you will get the coefficient of variation is equal to 17.285. Now by that we have to go for the optimum number of rain gauges formula, that we seen that n is equal to CV divided by AE, that is the error, bracket raised to 2.